Hi and salam sejahtera. Thank you to the panel for the time to watch my video presentation. My name is Mary Anyatomi, a bachelor degree Manufacturing Engineering Technology, Process and Technology. And first of all, I would like to express my gratitude to my supervisor, Professor Madya IRTS Dr. Muhammad Yuhasri bin Yaakob, and my co-supervisor, Dr. Muhammad Amir Hafizan bin Hussein, who has been guiding me with passion and sharing their knowledge to me throughout this research. The project title is Research and Development of Fire Retardant KENAF Fiber for Heat and Fire Insulator Application. The presentation outline will be introduction, problem statement, objective, scope of study, selected literature review, methodology, result, the best composition ratio, and the last one is conclusion. Natural fiber is an eco-friendly material with low energy consumption and of course a low cost. So basically, natural fiber is divided into three types. The first one is vegetable, mineral, and protein. The use of natural fiber in construction nowadays is very high due to the low impact of it on environment and human life. Thermal insulation is used in the development of heat transfer, where heat transfer is a mechanism which are radiation, conduction, and convection. So, thermal insulation is useful tool for preventing heat loss and reducing energy consumption. So, in thermal insulation, thermal conductivity is commonly used to assess the thermal insulation performance of heat insulating material. KENAF fiber is an economically viable and environmentally friendly alternative fiber crop. So KENAF fiber is a composed of multiple useful components such as stalks, leaf, and seed. So because of its lightweight, biodegradability, low cost, good mechanical properties, as well as good thermal stability and solid fiber metric adhesion, KENAF fiber was used as a reinforcement for composite. Next is fire retardant. Fire retardant is one of the most simple, cost-effective, and effective way to protect material from fire, and it is easily to process and may be used onto wood. So there are two advantages of fire retardant that highlighted here. The first one is it can stop heat from getting through and flame from spreading. And the second advantage is it has no effect on material inherent properties such as mechanical properties. Therefore, fire retardant can occur in both vapor and condensed phase. The problem statement for this study is there is lack of study of KENAF fiber used in heat and fire insulator application. The second problem statement is there is high production cost of insulator application nowadays. The next problem statement is environmental issue where the use of synthetic fiber give negative impacts to environment and human life. The next problem statement is natural fiber has low mechanical properties compared to synthetic fiber. There are four objectives for this study. The first one is to produce KENAF fiber with various fire retardant ratios for heat and fire insulator application. And the second objective is to investigate the properties of KENAF fiber with various fire retardant ratios towards high temperature. And the third objective is to evaluate the effect of fire retardant on acoustic properties. And the last objective will be to recommend the best KENAF fiber fire retardant ratios composition for optimum performance in heat insulator application. The scope of study for this research is to study the potential of KENAF fiber to be used in industry by considering the mechanical properties and cost. The second scope of study is to identify the suitable amount of composition of fire retardant to produce a good fire and heat insulator application. The third scope of study is to ensure that the fire and heat insulator application able to withstand a temperature up to 400 degrees Celsius. The next scope of study is to ensure that the heat and fire insulator have an effective soundproofing for acoustical properties. Then, in this research, also study the properties of sample when different ratios of KENAF fiber and fire retardant are combined. And the last scope of study is various testing such as thermal testing, fire test, and acoustic test will be made to investigate the relationship between KENAF fiber, fire retardant, and their ability to absorb energy and resist heat or fire. The literature review that highlighted in this study is thermal insulation useful tools for preventing heat loss and reducing energy consumption, which is mentioned by Jan 2018. Chiki also mentioned that natural fiber derived from a renewable resource require little energy to manufacture and easily dispose at the end of their life cycle by composting. Monet 2020 also mentioned that KENAF fiber was used as reinforcement for composite because of its lightweight, biodegradability, low cost, good mechanical properties, as well as good thermal stability. And the last literature that highlighted in this study is fire retardant coating stop heat from getting through and flame from spreading and has no effect, such as mechanical properties. The last literature review that highlighted in this study is fire retardant coating stop heat from getting through and flame from spreading and has no effect on its material inherent properties such as mechanical properties, which is mentioned by Gu 2007. So these are the methodology for this research. The first one is preparation of raw material, then preparation of mold, then fabrication process, followed by testing sample by following ASTM standard, then scanning electron microscopic analysis, and the last one is fabrication of prototype. This is the result and discussion for this study, and the manufacturing process that involve are mixing, soaking, drying, and molding. So for mixing, the fire retardant is mixed with water and put the KENAF fiber inside the mixture and let the KENAF fiber soak in the mixture for 1 day or 24 hours. Then after that, take out the fiber from the mixture and let it dry for 2 or 3 days in a room temperature. Then the last process will be molding process. After the testing is done, these are the results. For thermal transmission performance, we can see here the average of thermal conductivity of sample 1 until 7 was calculated. From the graph, we can see that sample 1 has the highest thermal conductivity with value of 0.4472 watt per meter Kelvin compared to the other sample. And the temperature difference of this sample is 240 degrees Celsius. And the lowest of thermal conductivity is goes to sample 6 with 0.3286 watt per meter Kelvin, where the temperature difference is 195 degrees Celsius. So sample 1 is basically content of 0% of fire retardant, while for sample 6, it contains the highest composition of fire retardant, which is 25%. From the graph also, we can see that the current insulator from industry, which is sample 7, has the third rank for this result with a value of 0.3934 watt per meter Kelvin with a temperature difference of 223.333 degrees Celsius. Next is the fire reaction performance of the sample. As we can see in the table, sample 6 has the highest average non-burn fiber percent, which is 98.103%, and the average burn fiber percentage of this sample only 1.897%. Sample 1 has the highest average burn fiber with 91.52%, and the average of non-fiber is only 8.472%. So as we can see here also, for the current insulator sample, which is S7, the non-burn fiber is only 11.389%, while the average of burn fiber is up to 88%. Next is the result of sound absorption performance. As we can see in the graph, sample 3 has the highest peak point, where at frequency of 1259, the coefficient is 0.9104, and at the frequency of 1600, the coefficient is 0.9091. And the lowest peak point goes to sample 4, where the peak point is only 0.8134 at the frequency of 1000. After go through all the testing results, so these are the best composition ratio for this study. So for the thermal transmission performance, the best sample goes to sample 1, which contains 0% of fire retardant. So this sample contains 100% pure KENAF fiber. When compare the result to industry sample, it has 12% higher in thermal conductivity. For the resistant performance, the best sample is sample 6 with the highest non-burn fiber compared to the other fiber. So when compared to the industry sample, it has 88% higher non-burn fiber compared to the industry sample. For the sound absorption performance, the best sample is sample 3, where at the frequency of 1259, the coefficient is 0.9104, and at the frequency of 1600 Hz, the coefficient is 0.9091. In conclusion, the objective of this study was achieved, where there are 6 different composition ratio of fire retardant successfully produced, and the composition are 0%, 5%, 10%, 15%, 20%, and lastly 25%. In this research, the KENAF fiber is compressed with cold press machine with moderate amount of pressure, and the dimension sample is 200 mm times 200 mm and thickness of 40 mm. The next objective was also achieved, where the effect of fire retardant in KENAF fiber is proven has an ability to insulate heat and fire better than current insulator used in industry, and the fire stop spread with high composition of the fire retardant added in the sample, and KENAF fiber is seen to having more ability to trap heat energy compared to the current insulator sample. Objective to evaluate the effect of fire retardant on acoustic properties was also achieved, where the composition of fire retardant in KENAF fiber and the density of the sample affect the acoustic properties, and also fiber that contain more fire retardant are observed to have lower sound absorption. The last objective was also achieved, which is to propose the best composition of fire retardant and KENAF fiber for an optimum performance. So the sample with high thermal conductivity is sample 1 with 0.4472 watt per meter Kelvin and the temperature difference of 240 degrees Celsius, and sample 6 with the higher percentage of non-burn fiber with 98.103% of non-burn fiber, and sample 3 is reaching the highest peak at 1259 Hz with coefficient of 0.9104, and at the frequency of 1600 Hz, the coefficient is 0.9091. So, this study is suggested that the sample can replace the current insulator that used in the industry. That's all for my presentation. Thank you.